3 is just about over. Big test coming up, kids. Yeah, that's a big test. By the way, students, if you haven't hit the subscribe button for Miss Newman and I, please hit the subscribe button. We could use a few more subscribers. If you haven't hit it, thank you very much. I appreciate it. If you haven't hit it, do it right now. No, I mean right now. Now do it right now. No, not later. Now. Oh, thank you. Okay, here we go. Ooh, so practice test. Now, if you are here to get the answers from me, what I want you to do is this. On the day of the test, I want you to raise your hand. If you're Miss Newman's class, just tell her to come get me. Raise your hand, say Mr. Krause, or to Miss Newman. Miss Newman, can you get Mr. Krause? And then I'll sit next to you, and I'll hold your hand, and I'll walk you through the problems. And we'll just get 100 on the test. We'll just do it. We'll just get 100 on the test. It'll be so easy. You and me together. Not a chance, bro. You got to do these problems on your own. If you're here just to watch me do the problems, it's kind of boring. And it's not going to help you on the test. It's really not. I promise you. I've been doing this a long time. Try them on your own. Come here if you need help. And that's what I'm here for, Mr. Key. So hopefully you're here because you need help. Not mental help, math help. All right. So I said graph the following function and answer all the questions. Okay, what is the equation for the axis of symmetry? Well, I know the formula is x equals negative b over 2a. So this is equal to positive 5 over 2 times 1. So that's just x equals 5 over 2. By the way, as usual, if you find a mistake in my answer key, bonus for you. Now I need to find the coordinates of the vertex. So what I need to do is I need to take this 5 over 2 and plug it in. So that's going to be 5 over 2 squared minus 5 times 5 over 2 minus 6. Well, the easiest way to do that on your calculator is just take 5 divided by 2 and store it into x. Hit enter. And then just type in the equation, x squared minus 5x minus 6. And it tells you it's negative 49 over 4. So my vertex is 5 over 2, comma, negative 49 over 4. Now, if you got, and if you did this on your own and you got 2.5, comma, negative 12.25, that's right as well. So I know I got to graph that point, 2.5, 12.25, 2.5, negative 12.25, so right around here. But I don't know what the other points are. I mean, I probably do, but I probably don't. So I'm going to go graph this. And it's x squared minus 5x minus 6, graph, there it is. I don't really care what that looks like. I'm just going to go right to the table. Take a look at these things and see what I can graph. I can't graph that, so I can graph negative 2, 8, and I should really show my values. I mean, that's part of showing your work, x and y. Negative 2, 8. Can't do that one. Negative 1, 0. 0, negative 6. 1, negative 10. And if you look at it, it'll be 2, negative 12. And then we'll just go the other direction. These are all going to be just mirror reflections over here. Oops. So, something like that. Try to hit the points. If it's a test day, do a good job. Some of you aren't very good at that. All right, what is the domain? Well, it goes forever and ever from negative infinity to positive infinity. It goes ever and ever left and right. What is the range? Well, here is my lowest y value down here at negative 49 over 4, and it goes forever and ever up. So bracket negative 49 over 4, comma, infinity. Now, again, if you wrote negative 12.25 to infinity, that would be fine. What is the y-intercept? Well, the y-intercept is right here anyway, so I don't need to do anything. It's just -6. What are the roots? Well, it hits at -1 and it hits at 6, even though mine didn't quite hit at 6. -1 and 6. Over what interval is it increasing? Now, you got to remember, increasing is as you're reading from left to right that it's going up. So that's increasing. So if I start here and I go off in this direction, I am increasing. But remember, increasing and decreasing, when you're talking about increasing and decreasing here, on both of these, you're talking about x values. So I know starting at 5/2 and going on forever and ever to the right, I'm increasing. Remember, we're using x values. So starting here and going in this direction, the graph itself is going up. Now, while I'm at it, as I read from left to right, all the way it's decreasing, decreasing, decreasing until it gets to here as well. So if I want the interval for which it's decreasing, that would be from -infinity up through 5/2, but not including 5/2. Concave up and concave down, we haven't really talked about that, but is it pointing up? It's concave up. If it's pointing down, it's concave down. Concavity will come into play next year. I just want you to get used to that terminology. It's concave up. And it is a min or a max. Obviously, it's a min. Draw a function that's increasing from -infinity to -3. Remember, these are x values. So I need to pick any point on the line x equals -3. Any point. I'll pick this one. Now I need it increasing starting from -infinity and going up. So as I read from this side to this side, it's increasing. So as I get going up and 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 up. But at this point, I don't want it to be increasing anymore, so I better start coming down. So there would be one that would be increasing starting from -infinity and going in this direction until I get to -3. Over here, I want a function that's decreasing from -infinity to 4. So I need a point that's on 4. 1, 2, 3, 4. So anything on this line, I'll just pick this point. Doesn't matter which one I pick. But I want it to be decreasing as I start from -infinity and go to the right. Decreasing, decreasing, decreasing. Oh, back up. So something like that. At any point, I could pick a point here and go like this. Any point, oops, except for that wasn't on the right line. As long as it's on the line on the line x equals 4, some point on this line. All right, we talked about this. Remember, the discriminant is the part that's under the radical. It's the b squared minus 4ac. So you need to know what happens when the discriminant is negative. That means the part under the radical is negative. That means we're going to have imaginary roots, which means no real solution. So when I graph it, I got to graph something that looks like this, never hitting the x-axis. I could graph that. I could graph that. I could even graph this. No, if I blow that up like really a lot, you'll see I didn't touch. So anyway, that's what having a negative discriminant means. It means that the quadratic will not touch the x-axis. Well, what happens when the discriminant is equal to 0? This is the only time we get a bounce. I call it a bounce. It's just going to come down, and it's going to hit the graph at one point. Something like this. One double root. I could make it over here if I want to. Parabola going down. Just as long as it hits it once. That would be a good sketch of something with a discriminant equal to 1. All right. If the discriminant is positive, we know it's going to hit twice. If it's a perfect square, that means it's going to hit twice at rational points. So if I wanted to draw one, I'd say, oh, okay, I'm going to hit this point, and I'm going to hit this point. Notice it hit 2 nice points. Of course, I didn't graph that very well. Let's try. I could put the point here, and I could put the point here, and I could say, okay, I'm going to have this parabola come down. It's going to hit that nice point down there, and it's going to hit that nice point right there. 2 nice points. If it's positive, again, we have positive. That means we're going to hit twice. But it's not a perfect square, which means I can't take the square root of it. Sorry about my nose. I don't know. So that means I'm going to hit at 2 not nice points. So I'm not even going to try. I'm just going to hit it twice. But I want to try to make sure that I go in between points. So I just draw something that looks like that. You know, if you want to, you can draw something that looks like this. That's awful. Graph, just as long as you see, hey, it's not hitting at nice points. Draw a function that's concave up. It just points up, right? Its concavity is pointing up. In this case, concave down. Very simple. Very simple. All right. So now we got some more work. We're going to convert this to vertex form, state the vertex, and no, I don't do the axis symmetry, but we should. We might. So remember, what we're going to do is we're going to add the same value to both sides. We're going to add something here, and we're going to add something here. Now that value comes from this. Sorry about my nose, it itches so much. Half the middle squared. So half the middle is 6. 6 squared is 36. So I'm going to add 36 to both sides. But notice I'm not putting these together. This part is the important part right here. So I'm going to factor that. F of x plus 36 is equal to x plus 6 squared plus 10. Now I'm going to bring the 36 over. So I get f of x equals x plus 6 squared minus 26. Now, how could I make sure I got that right? Because I'm a person that likes to make sure 100% I got that right. Well, the easiest way to do that is to do it like this. Come over here to graph mode. Graph the original, x squared plus 12x plus 10. Hit enter. It doesn't matter what it looks like. It's there. There it is. Did I hit it right? I don't even like that. Really don't like that. Oh, there's the rest of it. I just grab that and bring that over. See how I just click and bring that over like that? There's my parabola. Right? I can find the bottom of it if I want. See, there it is. Just clicking. Whatever. I graph it, see a picture of it now. Hit tab. And I'm going to put the answer I came up with, which was parentheses x plus 6 parentheses squared minus 26. And if I'm right, it should map right over it. And there it is, mapped right over it. So I know I'm right. I know I'm 100% correct. I come over here, and I'm going to write that function right here. So x plus 6 squared minus 26. Now, the vertex comes from these two. Remember, when you take it out of the parentheses, it's backwards. Otherwise, it's going to be normal. There it is. All right, here's another example. So if you didn't understand if you didn't get that first one and you couldn't get it, try this one on your own. Now, this one's a little bit more difficult because it's got the 3 here. So if you want to try it on your own, go ahead. But what we're going to do is we're going to kind of temporarily get rid of that 3. So I end up with f of x over 3. We'll bring it back, y'all. Is equal to x squared plus 6x plus 12. Now I'm going to handle exactly the same way I did it before. We're going to work on this, half of it squared, and we're going to add it to both sides. Plus 9 is equal to x squared plus 6x plus 9 plus 12. We're going to work with this. There's our work. We're going to work with that. F of x over 3 plus 9 is equal to x plus 3 squared plus 12. Oh, I found my mistake. I knew there was a mistake somewhere. I found it. It's right here. I just brain cramped. I looked over my answers and I realized it was a mistake. This shouldn't be 12. Sorry about that, children. Because I did 12 divided by 3. I should have gotten 4. 4 and 4. Okay. I knew something was wrong. I'm going to subtract 9. Subtract 9. And so what I end up with is f of x over 3 is equal to x plus 3 squared minus 5. Well, I'm not quite done yet. I still got to get rid of that 3. So what I'm going to do is I'm going to multiply both sides by 3. On this side, I got to distribute. So these just cancel. So I end up with f of x equals 3 x plus 3 squared minus 15. Now again, I'm going to grab my calculator because I'm not 100% sure. I think I'm right, but I'm not 100% sure. I'm going to grab my calculator and I'm going to go back in and I'm going to type in 3x squared plus 18x, 3. And now I would have found my mistake that I made right now had I not made it right away. Plus 18x plus 12. Hit enter. And then I'm going to type in my new one, which is 3 parentheses x plus 3 parentheses squared minus 15. Now, if I'm correct, it maps exactly over this. Oh, I didn't hit tab. Shoot. Parenthesis. You guys are probably, I forgot the 3. 3 parenthesis x plus 3 parentheses squared minus 15. If it's right, it maps exactly over this. There it is. And you can see it's right over there. And again, if you want, hit the tab button, hit the up arrow, and just keep clicking on this. There it is, on, off, on, off. See, it's the same thing. So I know I got it right. I'm 100% sure I'm right. So I come over here and I say, okay, my answer is 3 x plus 3 squared minus 15. And my vertex is negative 3, negative 15. Notice opposite sign, same sign. All right. Let's do this by completing the square. Your answers must be in simplest radical form. So complete the square. Bring the constant over to the other side and write it with 2 squares. X squared plus 8x plus square equals 2 plus square. Half the middle squared. So first thing I'm going to do is half the middle squared. 16. 16. So on the right side I get 18. Almost done. I'm getting there. I'm almost finished. Take the square root of both sides. Don't forget to put a plus or minus. You're going to lose some points. So I get x plus 4 equals. Now the square root of 18, I know I'm going to have to simplify. So hopefully by now you're getting good at this. 9 times 2. And the square root of 9 is 3. So this is plus or minus 3 square roots of 2. Now, don't be that kid that adds this 4 over, subtracts this 4 over, and puts it with the 3. It's not. It's x equals negative 4 plus or minus 3 square roots of 2. That's my answer. Negative 4 plus or minus 3 square roots of 2. Now, again, I would love to know if I'm right. I want to know every single time. There it is. I don't know if my big head's in the way. If I'm right. So what I'm going to do is I'm going to stow this value. There it is. I don't know if you can see it. I'm going to stow that value into my calculator. So I'm going to go over to calculator mode. Negative 4. And I'm going to do the plus. I only need to do one of these. If one of them works, I know the other one works. At least as far as these go. Control var x. I'm going to store that. And my original question was x squared plus 8x minus 2. Now, I know I'm correct if this turns out to be 0. I'm 100% correct. I know I'm right. Please use the calculator to check your answers. You'll know if you're right. I'll be back. When I work on my practice test, I drink nothing but the best. D&D Dunkin' Donuts. Yes! Nailed it! All right, oftentimes when you read the directions, who reads the directions? That's just crazy. Why would anybody ever read the directions? Read the directions. There it is. Simplest A plus BI form. Wait a second. Is that an I? Do I see an I? Does that mean my answer is going to be imaginary? You're damn right. You're darn tootin'. So let's get started, baby. Bring the constant over. Nothing's new. We're going to write it with two squares. Half the middle squared. Okay, half the middle. Somebody asked me today, how do I know what's half the middle? Well, half the middle is -3. They're like, do you put a plus in there or minus? What's half the middle? -3. -3 goes in there. It's whatever that sign is. This will always be positive because I'm always squaring it. 9. So I end up with -12 on this side. So now I grab my calculator or my thing, take the square root of both sides, take the square root. Notice I have a negative under the radical. Alert, alert, I is going to be in your answer. I hope you get it right. Oh, God, the comedy is amazing. X minus 3 is equal to. Now, the square root of -12, maybe I'll pop over here and do something with this. It's -4 times 3. What's the square root of -4? 2i. So this becomes 2i squared to 3. So, oh wait, almost forgot my plus or minus. That would be really bad. Plus or minus 2i square roots of 3. Now, when you bring this 3 over, don't put it with this. It just goes out in front, 3. So my answer is x equals 3 plus or minus 2i square roots of 3. So my answer is 3 plus or minus 2i square roots of 3. Gosh, I wish I could find a way to check my... I can check my answer on my calculator. Oh my God, that's crazy! Crazy, crazy, crazy. I can't believe it. So 3 plus... Now, you got to be careful with this. It's 2 times... Got to get down here and get your I times... Always be more cautious, the square root of 3. And we're going to take that and we're going to store it into x. And it's going to give you some weird looking thing. There it is. And now I'm going to type the problem I had. The problem I had was x squared minus 6x plus 21. And I'm hoping I get 0. Goose egg. There she be. Why not check your answers? Check your effing answers. The fun answers, the fraction answers. You know what I meant. Gosh, you potty mouse. All right, here we go. We're going to change from standard form, and then we're going to identify the center and the radius. So you remember correctly, we're going to be doing completing the square twice. So x squared plus 8x plus the square for the x's plus y squared minus 22y plus the y for the box for the y's is equal to 13. Notice I brought it over. It becomes positive plus square for the x's plus square for the y's. All right, let's see what goes in these things. What's half the middle? Oh, that's half of 8 is positive 4 squared, 16. 16. Plus, what's half of negative 22? Oh, that's minus 11. Squared is 121. I feel like I've done this problem. Oh, I know why. I just did it the other day. So I equals 150. So, okay. There's the equation. Let's get that written down. I've written it in center radius form. X plus 4 squared plus y minus 11 squared equals 150. Well, I still have to find the center. That's pretty easy. It's sitting right there. -4, comma, positive 11. But remember, this thing here at the right side, this, is equal to the radius squared. So the radius squared is equal to 150. So the radius is equal to the square root of 150. But I really shouldn't enter that as my answer. I need to find the perfect square that goes into 150. And hopefully you know that's 25 times 6. And the square root of 25 is 5. square roots of 6. And so that's why I picked that as my answer. Okay, this page ought to go pretty quickly. These are pretty simple questions. I just want to graph this. But I need to show work. It's not okay just to come over here and graph it like you're some genius. You have to show a little bit of work. So you're going to say, okay, Mr. Krause, I know that the center is 4, 0. Opposite, and there's no number with this one, so it's 0. I know that the radius is equal to 3. Remember, that's radius squared, so to come back, it's the square root of it. So I come over here and I say 1, 2, 3, 4. There's my center. I'll go up 3, left 3, down 3, right 3. Do me a favor. Don't make your circle look like a square. If I could do it on this, and trust me, this is really hard to make it look like a circle, you can too. All right. That was easy. Come down here. My center, Mr. K, is 0, negative 2. Remember, opposite signs. My radius is equal to 1. It's just the square root of 1, but it's 1. So I come down here to 0, negative 2. Put a center. Up 1, left 1, right 1, down 1, and draw me a circle. All right. Write the equation of a circle centered at 5. Now this one's got to be like, you got to love this question, except I threw a little trick into it. The circle formula is this. And then on this side goes radius squared. So I'm going to come down here and I'm going to say x and y. Remember, when they go in opposite. Minus 5 plus 6. Now, here's the trick. I didn't give you the radius. I gave you the diameter. Therefore, the radius is equal to 7. Therefore, what goes here is 49. Just be careful of the wording. You never know, could be a jerk. I'm not a jerk. All right, here we go. This is my passing through the point and centered at this. So, be careful. Pick the right point. Squared. This is its centered. It's centered here. So this is going to be x minus 0. That's kind of boring. Plus y, remember, goes in with the opposite side, 1 squared equals, now over here I need the radius squared. But then I got to find a little bit of work. I got to find the distance between these 2 points. So I know the distance formula is equal to the square root of x1 minus x2 squared plus y2 minus y1 squared. I call this the distance, but it's really the radius. So I'll call it r. R equals square root of, let's say, negative 4 minus 0 squared plus 2 minus negative 1. Careful with your signs there, squared. So this is r equals square root of 16 plus 9. R equals the square root of 25. R equals 5. Now, remember, r squared goes here. So what I need here is a 25. And there's my answer. Oh, wait, I don't like that. Let's write it like this. X squared plus y plus 1 squared equals 25. That's a better way to write it. There it is. There's my answer. All right, we're moving. Let's see what we got. Oh, here we go. Everybody's favorite. So Megan McGuinn says she can throw a lacrosse ball over 200 feet. Mr. Clark has been measuring all of the metrics for the ball leaving the lacrosse sticks and has come up with the following function to model the behavior of the ball leaving her stick, where h of x represents the height in feet and x represents the distance in feet the ball travels up the field. So, hopefully you've answered these questions already. You're not here just for my answers. So, at time 0, if I plug in a 0 here, I'm going to get this as my answer. And they're saying, okay, what does that represent in real life? Well, the plus 8 at the end of the function, which is the y-intercept, is the height of the ball. So it is the height of the ball just before it leaves Megan's. Oops, I forgot the A. Sorry, Megan. Megan's lax stick. So you think about it, she's throwing it in the air. It's about 8 feet in the air. That's how high the ball is just before it leaves her stick. How many linear feet along the ground will the ball be at its highest point? Okay, so clearly we have to graph this sucker. And so what I'm going to do is I'm going to come back and answer those questions after I've taken the time to graph it. So we're going to graph it. We know we want only the first quadrant, so we know we want this to be 0 and this to be 0. But we need to graph this thing, so let's take a look. Let's see. Control division -1 over 125, excuse me, x squared plus control division 3 over 2x plus 8. And you're going to get some, okay, completely useless, right? Completely useless. Notice my y-intercept is right here about 8. Okay, but this is useless. I need to see more. So I'm going to click on this. And I'm going to delete it. And I don't know. How high does a lacrosse ball go? 100 feet? And she said she could throw it over 200 feet. So I might make this 300. Ah, that's pretty good. That's pretty good. So I'm saying my y values are going from 0 to 100. And maybe this is a little bit much. Maybe I'll make it 250. Ah, okay, that's even better. 0 to 250. So I come back over here and I say, okay, my x mins are going to go from 0 to 250. My y mins are going from 0 to, what do I go? Up to 100. Now again, I'm above, but I want to be above. I want this window to be slightly bigger than what I need it to be. Table start's always 0. Well, I don't know what my step's going to be or should be until I really look at this thing. So let's see, Control T. And I look and I look and I look. 5? Do I want to make it every 5? Because if I made it every 5 and I have to get up to 250, that's going to be like 50. I don't want to do that. 10? Maybe. 15's okay. I don't know. Maybe 20. Maybe every 20. Yeah, every 20 sounds good. Look, 20 is 35. So if I make this every 20, that'll be okay. That'll give me 10 boxes. So that's what I want to do. I'm going to make my ticks every 20. 20, 40, 60, 80, 100, 120, 140, 160, 160, 200, 220, 240, 240, 260. So I went out 260. Maybe I could have made it a little bit bigger. And it only looks like it's going up. Maybe I should find out what that is. Let's hit Control T. Let's find out what that max is. Menu, analyze the graph, maximum, click, click. There it is. It looks like I only got to get up to about 94 feet at 78. But I also need this x-intercept over here, so I might as well get that too. That's called a 0. Root or 0. Click on that. Click, click. Oh, it looks like she's going to only go 193 feet up the field. So I'm going to pick the important parts. Let's go up by 10. 10, 20, 30. Oh, I hope I can get up there. 40, 50, 60, 70, 80, 90, 100. All right. So if I'm drawing a quick sketch, and I go to the table, Control T, I'm going to just check every 20. So I'll go to Menu, Table, Edit Table Settings, and I'm just going to change this to 20. All I want to see is all the 20s. So 0, 8, we knew that. 20 is 35. Uh, 40 is 55. Let's see, 50. 70. So 40 is 55. 60 is 70. Oh, we might as well get that maximum. What was that maximum? 94 and 78.3. So 94, there's 90. 94 and 78.3. So that was like right here, somewhere around here. Let's see what we got. There's 80 and 77. 80 and 77. And 120 and 73. 120 and 73. Oh, if that's 120, and this is not 94. This is 100, so 94 is probably right about here, actually. So, and then we know it's going to land at 193. So this is 180. This is 190. So it's going to land somewhere around here. So it's going to go up. And it's going to come back down. I could plot more points, but we'll be here all day. And there it is. So I know this point right here, up here, is 93.8, comma, 78.3. I know this point right here is at 193. Exactly 193. I don't see it here, but I know it's here. So Control T. So let's go answer the questions. After how many linear feet along the ground will the ball be at its highest point? At 93.8 feet. At 93.8 feet. What is the maximum height of the ball? 78.3 feet. Now, the only question I didn't ask, which I should have, was Megan right? Will she be able to throw? Does she throw the ball 200 feet up the field? No, the maximum she'll throw the ball up the field is 193 feet. Got to work on it, Megan. Are you ready for the hard stuff? Oh my God! I am. Oh my God, are you ready? Scared ya. Let's get back to work. Yes, I know. I have way too many fillings and bad teeth. All right, let's get back to work. Here we go. We're going to derive this analytic equation between this point and this directrix. Now, I know we haven't done this since last week. It's been like a week. So we got to pick a point. Our point is going to be x comma y. So we're going to do the easy equation. The easy equation is the distance between this point, y, and this directrix, 4. So it's y minus 4. The harder one is the distance between the 2 points. And that would be x minus 4 squared plus y minus 6 squared. All right. Well, the definition of a parabola using focus and directrix says that these two equations must be equal to each other. So that's what we're going to do. We're going to set those suckers equal to each other. So d minus 4, not d, y minus 4. Y minus 4 is going to equal the square root of x minus 4 squared plus y minus 6 squared. So we're going to square both sides to get rid of that square root, Now, double distributing this, don't forget, it's going to be y squared, double the negative 4, negative 8y, plus 16. These cancel each other out. But I still got to double distribute this, and I have to double distribute that. So this is going to be equals x squared minus 8x plus 16 plus y squared minus 12y plus 36. So if you're having a hard time double distributing this stuff, write it out. Y minus 6, y minus 6, and then do all that math. I hope you get to a point where you can just double the middle, and that's the hard part. All right, let's see what we got. So this y squared is going to cancel with this y squared. And believe it or not, this 16 cancels with this 16. Now we need to bring the y's over to the same side. So I'm going to add this 12y. And I'm going to add this 12y. So I get 4y equals x squared minus 8x plus 36. All the stuff that's left over. Well, I'm almost done. I just have to divide by 4. So I get y equals 1/4 x squared minus 2x plus 9. There it is. Only took 3 minutes. Let's try another one. And some screaming. So we're going to do the easy one. First thing I do is pick a point. Point's going to be x comma y. We're going to find the easy distance. D equals y minus 2. Now we're going to find the harder distance. D equals the square root of x. Now be careful here. We got negatives. Anytime there's negatives, you got to be careful. It's minus negative 2 squared. That'll end up being a plus. Plus y minus 4 squared. Just be careful of those negatives. So if this is true, this has to equal this. So I end up with y minus 2 equals the square root of x. I'm going to change this to plus 2 now. Plus y minus 4 squared. I'm going to square both sides. Double distributing stuff. Lots of double distributing here. I hope you're getting good at it. This is y squared, double the negative 2, plus 4. So double it, square it, is equal to, gone, x squared, double it, 4x, square it, plus 4, plus, almost there, plus y squared minus 8y plus 16. Let's cross stuff off. The y squareds go. They better. I also get rid of these 4s. And I'm going to add this 8y over. So I get 4y equals x squared plus 4x plus 16. Divide by 4. Divide by 4. And I get my final answer is y equals 1/4x squared plus x plus 4. How'd y'all do? All right. All right, children, got one more of these. Okay, we're going to pick our point. Our point is x comma y. We got our focus. We got our directrix, but I'm not telling you the equation, but there it is. It's the x-axis, and you have to remember that's the line y equals 0. So we'll do easy between this and this. So the distance is equal to y minus 0 or just y. Well, that ought to make things a little bit easier, I think. And then the harder distance is going to be equal to x minus 6 squared plus y minus 2 squared. Going to set these bad boys equal to each other. So y is equal to the square root of x minus 6 squared plus y minus 2 squared. So we're going to square both sides. So I end up with, well, just y squared over here is equal to, now I'm going to have to, this cancels, but I'm going to double distribute again, so get good at this, kids. X squared, double the negative 6, I get negative 12x plus 36 plus y squared minus 4y plus 4. Hopefully your y squareds cancel. So I need to bring this 4y over. So I get 4y, that's weird how I keep getting 4y, I got to stop that, is equal to x squared minus 12x. Now these two I got to put together. Plus 40. Divide by 4. divide by 4, and I get y equals 1/4 x squared minus 3x plus 10. Yay. All right. Find the zeros in the following statements in simplest radical form. Well, if I got to find the zeros, I'm going to set this equal to 0. And I don't really need this anymore. And I hate having a negative x squared. It's just a ginormous problem. So I'm going to move everything over to the right side. So I get 0 equals. So all of this stuff, I'm going to move to the other side of the equation. 0 is equal to 3x squared minus 10x plus 6. Trust me when I tell you, it's just a lot easier. Now, I don't want to do completing the square because I have to divide by 3, and that would be a problem right there. So just completing the square is just not going to work. So we're going to use our quadratic formula. Now, notice I want the answer in simplest radical form, and I want it rounded to the nearest hundredths place. And I'll show you what I mean by that at the end, okay? So A equals 3, B equals negative 10, C equals 6, and the discriminant, which is b squared minus 4ac, is equal to 100 minus 4 times 3 times 6. Let's see. 12 times 6 is 72. So I believe this is 28. Let me just look at my notes. Oh, I think my notes said yes. So here we go. X equals negative b, which is 10, over 2 times 3, which is 6, plus or minus the square root of 28 over 2 times 3. So I got to simplify the square root of 28. So I can do that right here. This is equal to the square root of 4 times 7, which is 2 square roots of 7. So this is really just 2 square roots of 7. So as I think about simplifying it, this is 10 over 6. So this is what I get. X equals 10 over 6 plus or minus 2 square roots of 7 over 3. Over 6. Now the reason I want to put a 3 there is because I know that these are going to cancel. And I know 2 goes in here 5 times. So I know this is going to reduce to 5/3. So my answer in simplest form is 5/3 plus or minus 2 square roots of 7 over 3. That's my final answer. Now, I would love to know if I'm right, because that answer looks stupid. I mean, who comes up with stupid answers like that? So control division 5 over 3. I'm just going to choose the plus. Control division, the square root of 7 over 3. And I'm going to store this into x. You can almost check almost everything on this text. Get used to it. Store it into x and type it in. 3x squared. Oh, it's negative 3x squared plus 10x. Now I'm going back to the original. Always go back to the original. Minus 6. Now if it doesn't equal 0, I did something wrong. Equals 0. I'm in great shape. Now I said I want the answer in simplest radical form. That's the green answer. I also wanted the decimal answer. Okay, well, if I want the decimal answer, I got to come up here and see what this is as a decimal. And I type this in my calculator, I get, 2.548. I said rounded their hundreds place. So I get x equals 2.55. X equals 2.55. But I also need the other one. So I have to hit this up arrow, go back, change this to a minus, and hit enter, and 0.78. So my two answers are 0.78 and 2.55. So I could ask you for the rounded answer, or I could ask you for in simplest radical form. You got to be available and conscientious enough to think about what is it that they are asking for. All right, here we go again. Again, we're going to use the quadratic formula on this one. So, and I'm going to set it equal to 0, but I don't want to move anything because A is positive. So A equals 5, B equals 6, C equals -3, and then D is equal to 36 minus 4 times 5 times 3. So this is equal to times -3. 96. This is equal to 96. So come in here. This one's a little bit easier. X equals -b is -6 over 10. 2 times 5 is 10, plus or minus the square root of 96 over 10. So square root of 96, I got to simplify it. May take you a little while, but eventually you'll get at it. 16 times 6. Square root of 16 is 4. So my answer is, oh wait, hold on. This is really 4 square roots of 6. So let's see. -6 over 10 is really -3/5, plus or minus, let's see, 2 goes in there twice, 2 goes in here 5 times. So 2 square roots of 6 over 5. So there's my answer in simplest radical form. I got to come over here and say, okay, -3 divided by 5 plus 2 square roots of 6 over 5. I forgot my calculator does some weird stuff. So 0.379 or 0.38. And now I need the other one. Plus. I don't know why I did minus first. 1.58. 1.58. Hey, we only got 5 more questions to go. 5 more. 26, 27, 25, 26, 27, 28, 29. We're almost there, kids. All right, so these two aren't, I hope you're still with me. These two are not that easy, but they're not that bad. They're not that bad. So what we're going to do is we're going to take each one of these points and we're going to plug it in. So we're going to use the point 115. So in for y goes 15. In for x goes 1. Well, 1 squared is 1, so that just ends up with a, plus 1 times b, which is just b, plus c. That was really boring. Now we're going to plug in this point. We need a different color. 331. So this one will be a little bit more exciting. 31, I'll actually show this work. A times 3 squared plus b times 3 plus c. So this one turns out to be 31 is equal to 9a plus 3b plus c. There's my second equation. Oh, I got a negative. Good. All right, so I'm glad I decided to pick a negative here. So we got -2, 6. So we're going to do 6 equals a times -2 squared. That's going to be positive 4 plus b times -2 plus c. So I end up with 6 equals 4a minus 2b plus c. So before I do anything, I'm just going to answer the question. What is a? What is b? What is c? And what is my final answer? We're going to go to the calculator and do that. So in order to do that, we go into calculator. I'm going to clear all this out so you get a nice fresh history. Okay, so we're going to go into menu, algebra, systems, solve a linear system. 3 equations. Now, in order to get to the next point, because I know you guys keep pressing like the down arrow and like, oh, wait, that's not working. Hit this tab button. It takes you to the next thing. Delete all that. A, comma, B, comma, C. Click OK. Now, my 3 equations were A plus B plus C equals 15. A plus B plus C equals 15. 9a plus 3b. 9a plus 3b plus c equals 31. Sound like Obama. Blah, blah, blah. The next one is 4a minus 2b plus c equals 6. Enter. So there are my answers. 1, 4, and 10. 1, 4, and 10. That means a is 1. So that's x squared, 1x squared, plus 4b plus 10. Now, I think that's right, but I really want to quadruple check. So I'm going to go graph this sucker. I want to know before I finish, is that truly my answer? X squared plus, this should be 4x. See, I already saw a mistake I made right here. Look at this. This should be x. This should be 4x, not 4b. So I already would have caused some problems there. Plus 10. So there we go. I fixed something. Plus 10. Enter. Now, I'm not going to know until I go to my table. Control T. I need to find those points. 115. There it is. 115 right there. 331. There's 331. And so the only one I need to find is negative 26. And there it is, negative 26. So I know 100% this is the right answer. Now, I got to get the work to do it. I got to get this work over here to do it. So I'm going to take these two. Now, again, I'm going to multiply this one by negative 1. So I get 15 equals a plus b plus c. Negative 31 is equal to negative 9a minus 3b minus c. Notice my c's are opposites. That's what I'm looking for. Cancel. Negative 16 is equal to negative 8a minus 2b. Equation number 1. Now I'm going to use those same two equations, this one with the negative, negative 31 equals negative 9a minus 3b minus c, and this one, 6 equals 4a minus 2b plus c. C's cancel. So I end up with, let's see, this is negative 25 equals negative 5a minus 5b. Now, the cool thing is when I'm done, each time I ought to know if I'm going to have the right answer or not because I already know what the answer should be. So let's go down here. We got negative 16 equals negative 8a minus 2b. And negative 25 is equal to negative 5a minus 5b. Hopefully I didn't make a mistake. I feel like I made a mistake because I don't remember this at all. This is looking weird. Weird. 4a to be or not to be. Well, that's the question. Okay. Well, I got to get a pair of opposites. So what I'm going to do is I'm going to multiply this top one by 5 and this bottom one by negative 2 because this will give me negative 10 and this will give me positive 10. So I get negative 16, got to multiply by 5, so negative 80, that's already scaring me, is equal to negative 40a minus 10b. And this is going to give me positive 50 equals positive 10a, positive 10b. All right, the b's go. And I get negative 30 is equal to negative 30a. All righty. Divide by negative 30, I get a equals 1. So although I was nervous, I can already check that one off. I got that one right. So I'll plug that a in. Doesn't matter which one. I'll plug it in right there. So negative 25 is equal to negative 5 times 1 minus 5b. Well, this is really just negative 5, so I'm going to add 5. Add 5. And I get negative 20 is equal to negative 5b. Or divide by negative 5, I get b equals 4. Ka-ching. And finally, I'm just going to grab this first equation, this one right here, and I'm going to say, okay, 15 is equal to a plus b plus c. 15 is equal to 1 plus 4 plus c. This is really just 5. If I subtract 5, I get 10 equals c. Ka-ching. Now remember, this is your actual answer because that's what it's saying. It says find the equation in the form. That's our equation. That's our answer. All right, we got one more of these suckers. Now, by now, I've done so many of these over the last couple of days, you should be able to do them. Pause the video, try it on your own. Little Dunkin' Donuts refresher. All right. Now, you should have already paused this. Here's what I would do. Pause it, and then come back when I got the 3 equations. Make sure your equations match. Now, if you don't have the calculator at home, you can't check your answers, but then I would solve it and see if you come up with those 3 answers. Now, if you want to, scrub all the way to the end of the problem, write down what the answers are, and then go back and then just see if you can get there. If you can't get there, figure out, go back and see if you can find your mistake. That's the way you should do this, not just copy what I'm going to write, okay? So the first point I'm going to use is 1, 4. So you should have already paused it. Hey, you're back. Oh my gosh, good to see you. 4 equals. Now, plugging in 1 is kind of boring. It's a times 1 squared. That's a. Plus b times 1. Well, that's just b plus c. So I gave you another easy one. Then we're going to use, then I gave you a hard one. -1, -2. So this is going to be -2 equals a times -1. Now this one I'm going to plug in. Plus b times -1 plus c. So this is -2 equals a, because -1 squared is just 1, minus b plus c. So there's my second equation. There's my first equation. And then finally, I'm going to type in 13.2. 13.2. Oh, whew. 213. Got that backwards. That was a weird one. 213. So 13 equals a times 2 squared plus b times 2 plus c, which is really just equal to 13 equals 4a plus 2b plus c. Gosh. All right. Let's get them together. I'm just going to get rid of c's like I always do. So I'm going to multiply through this one by -1 again. So 4 is equal to a plus b plus c. Remember, everything gets multiplied through by -1. So this is 2 equals -a plus b minus c. Well, that's really weird. I get... Oh, wait, hold on. Before I continue, I want to check. I want to get my answers. What am I, crazy? I didn't even get my answers yet. So, menu, algebra, solving a system, solving a linear systems. We're going to go 3, a comma, b comma, c. Click OK. So, a plus b plus c equals 4. A plus b plus c equals 4. A minus b plus c equals, I believe it was -2. And 4a plus 2b, 4a plus 2b plus c equals 13. Yep, there we go. All right, a is 2. B is 3. And C is -1. That means my answer is y equals 2x squared plus 3x minus 1. Now that is weird. Okay, so that's weird. So let's go see if it's right. So a graph, we're going to graph 2x squared plus 3x minus 1. Now, if I can't find those 3 points in my table, I did something wrong. So I need to find 1, 4. There's 1, 4. -1, -2. There's -1, -2. And 2, 13. There's 2, 13. So I found them. I'm right. So I know I'm in good shape. Let's see what we got here. So 6, the A's cancel and the C's cancel. That's weird. Equals 2B. So B equals 3. Wow. That was easy. So now let's take these 2 equations. So I'm going to still end up with 2 equals -a plus b minus c. And this is 13 equals 4a plus 2b plus c. Let's put these suckers together. So I get 15 is equal to 3a plus 3b, and the c's cancel. But I already know what b is, so I might as well plug it in, right? 15 is equal to 3a plus 3 times 2. That's 6. So subtract 6. I get 9 is equal to 3a, or a is equal to 3. And that's not what I have. So we've got a problem. Got a problem. Can we find it? See how I was able to I was able to do some work, but then I said a equals 3, and I come up here and I said this is a isn't 3, a is 2. That doesn't check. What mistake did I make? Did you see it? Did you see when I made it? I see it. It's right here. I plugged in what number? I plugged in 2. I should have plugged in 3. And 3 times 3 is 9. If I subtract 9, I get 6 is equal to 3a, or a is equal to 2. And then I can check that off. So knowing these answers ahead of time helps clarify your thinking. Now the cool thing is all I got to do is grab this sucker and I'm done. 4 equals a plus b plus c. 4 is equal to 2 plus 3 plus c. This is 5, so subtract 5, and I get negative 1 is equal to c. Check mark. Remember, this is your final answer, and we're done. We got it. We nailed it. All right, I only got 3 easy problems left, and we're finished. All right, this page actually is going to take about 2 minutes to do the whole page. We'll get this done. This says to me, when is f of x less than 0? Well, less than 0 means negative. Graphically, it means below the x-axis. So when is this function below the x-axis? Starting here and going, remember we use x values, in this direction, it will be below. Starting here, going in this direction, it will be below. So remember, you have to use the x values. The only time we use the y values is for, well, obviously, y-intercepts, but for range, and then min and max. That's it. So from negative infinity up to negative 2, but not including it because it doesn't have equal to, or starting at 6, going off to positive infinity. And then obviously this is pretty easy. Negative 2, 0, 6, open circle going to the right, open circle going to the left. This one says, when is it greater than or equal to 0? That means positive or above the x-axis. So I got to figure out when this is above the x-axis. Oh, okay. Starting from negative infinity up to and including negative 2, because we have an equal to, union 7, including 7, all the way to infinity. Negative 2, 0, 7, closed circle this time. Arrow, arrow. All right, one last one, sisters. When is this? We're at greater than again. Greater than means above. So in this case, it's a little bit different. This is all the stuff that's above. This is all the stuff that is when it's positive. Well, that's between negative 1 and 7. And it's got an equal to, so we'll include negative 1, 7. All right. Close circle at negative 1. Close circle at positive 7. In this case, I connect the dots. Sort of connect the dots. All right, that's it. That's the freaking practice test. It's over. Study, kids. Study. I'll be after school on Thursday afternoon. Of course, this is not 2016. It's whatever day the test is on. I will be on the after school the day before the test. And you can ask me whatever you want. We'll talk about questions. Remember, it's on Friday and Monday this year. All right, kids. Good luck. Study, study, study. I'm wishing you luck and crossing my fingers. You know how you can bring luck to yourself? Study! Oh my my God, it's so easy. Bye. Hit that subscribe button.